but more or less civil related to general topic also. Means
Yes.
everybody knows what is tunnel. I think everybody knows. Sir, it's my screen is visual, sir.
Yes, sir.
It is coming.
Yes, yes. Full screen.
Okay, sir. Full screen, okay, na, sir.
Yes, sir.
Okay, sir. Can we start, sir?
You can start.
Okay, sir. Okay, sir. So today topic is face to software for tunnel design. So first of all, I would like to introduce my department vision and mission. Department vision is to produce high competent ethical civil engineering professionals with globally perspectives for the catering to local, national and global needs, and evolving department to provide state of the art consultancy, research and development in the field of civil engineering and its aligned areas. Our department mission is to produce high caliber civil engineers by providing rigorous hands-on education with innovative and original thinking in the minds of budding engineers to face the challenges of future. With continuous interaction of industries, research, or organizations, and eminent professionals, enriching the curriculum and setting the department as center of excellence for academics, consultancies, and research in the field of civil engineering and allied areas. So, by including the field activities, certificate programs, professional and ethical values to our department for students in order to make them prepared to face the competitive world so that they can get the easily jobs in the competitive world. Now, move on to first is my topic is related to tunnel. It deals with the what is tunnel. It is a opening in the your rocks. First, before going to rock, what is geology? Means geo means earth, logy means steady or speech. Geology means study of earth. This is taken from the net. The famous Scottish geologist James Hutton. He has given the he has the father of modern geology. Now we see the earth. What is earth? You know, earth is a skin of earth. It is having three layers. One is crust, mantle, outer core, and inner core. We are living in the crust areas. We are living in the crust area. Crust area is from 3 to 40 miles thick. This is our crust. These are crust areas. Next one is our mantle. Nothing but a deepest layer of warm rock accounts for two-thirds of the mass of our planet. This is our mantle. Next one is outer core, inner core. Outer core is made up of molten iron, nickel, and other ingredients. Then steaming possibly several miles per week. Then the inner core. The outer core is movable. That is it is like a portion of liquid. The inner core is very solid. It is unable to move. It will not move. It is like a ball of iron alloy. The one third of the size of the moon in the center of the earth. This metal is boiling at a hot degrees of 11,000 degrees Fahrenheit comparable to the surface of the sun. But it remains solid because of the enormous weight of the all rest of the earth bearing down on it. So whatever the weight we are giving, that will be carried by the inner solid core. So what is tunnel? It is nothing but it is an underground or underwater passageway dug through the surrounding soil or earth or rock. So we are going to a underground. It may be a traffic, it may be a transportation, it may be a railway tunnel, or it may be for passes of your water, hydraulic producing current from the hydraulic industries. That is hydroelectric projects. Then carrying the waters. This could be used for carrying freights and passengers. Water, sewage also. Some cities will go for underground sewages. So a tunnel may be of a foot or vehicular road traffic, for rail traffic, or for a canal. Secret tunnels are built for military purpose. So for military purpose, the military people will give the secret tunnels. They excavate tunnels for hiding the soldiers at the time of wars. Then special tunnels such as wildlife crossings are built to allow wildlife to cross human-made barriers. So for without damaging the biodiversity, we are going to dig tunnels to protect the wildlife. For this also, we are using the wild tunnels. So the methods involved underground operations known as tunnel driving and surface not is disturbed. So surface disturb చేయకుండా we are going for underground. History. So first tunneling was done by prehistoric people seeking to enlarge their caves. So earlier days we know that the humans are living in the cages or caves. For caves they have to expand to build a tunnel. So first tunnel in Babylonia was a brick-lined pedestrian passage from having some 3,000 feet, that is 900 meters long, was built about 2180 to 2160 BC under the Euphrates River to connect the royal place with the temple. The largest tunnel in ancient times was 4,800 foot long, 25 foot wide, 30 foot high road tunnel between the Naples and Pazuloi exit in 36 BC. In the way back, the civilization starts. From there, they dig the tunnel. Then, in 1681, gunpowder was first used for blasting tunnels. So, for removing the rock or hard soil, they use the gunpowder to blast these tunnels. Then, after blasting, you will get the fog, having the muck, having the air gases. So, for that, we provide the ventilation system to whatever the workers working in the inside the tunnel, they have the breathing problem. They don't have the breathing problems. For that, they provide the ventilation. Then we move to the dip and stake. What is dip? What is stake? Dip is nothing but it is a means a slope of inclination. The angle of inclination of a bedding plane with the horizontal plane is called the amount of dip. So how it is dipping? From the it is dipping as east or west. The maximum angle is 90 degrees. So it will dip 0 to 90 degrees. So what it dipping means how the rocks are forming at the time of eruption of rocks. So the direction along which the inclination of the bedding plane occurs is called dip direction. So a direction low the dip is occurring under the ground surface. So the dip is expressed in terms of amount and direction. So dip anadhaniki they having amount as well as direction. Amount means 0 to 90 degrees or direction means how it is dipping in the area. So direction angle is measured by using the instrument called clinometers. So the direction is measured with the compass. So you can see here the direction of north. This is the water is present there. This is the dipping of the layers of the rocks, sedimentary beds or rocks. This indicates the direction of dip. This indicates the angle of dip. That is amount. This is the amount. This is the direction of dipping. Okay. Next, strike. What is strike? Nothing but it is a direction of a line formed by the intersection of a bedding plane and a horizontal plane. So it is a direction of a line. It is forming when intersection of a bedding plane as well as horizontal plane. So this is the bedding plane. Here, this is the bedding plane. This is the horizontal plane. For that, it is showing the strike. It is always right angles to the true dip direction. So strike and dip are mutually perpendicular to each other. It is a horizontal line. You can see here. This is the dip is moving like this. Strike is like this. So it is having this is the instrument used for measuring the strike and dip. So why I'm telling is because when you go the design of tunnel, you have to know what is strike, what is dip, what is direction, how the rock is bedding, how it is a folding. You can see the beautiful of rocks is folding. So it will fold due to the immense pressure and temperature acting on beyond the surfaces. So when a set of horizontal or rock layers subjected to a compressive force, then undulation or bends occurs developed in the rock layers. These are called as folds. Next one is fault. What is fault? Nothing but a fault may be defined as fracture surface along which a relative movement of adjacent blocks has taken place. This is the fold. This is your fault. So here this layer and this rock will be forming a fault. So it is a development of fracture. Means between the rock layers, the fracture develops. Because of the fracture, you will get from the fracture, you will get the earthquakes. So because of the movement of the tectonic plates, the tectonic plates are always moving from rotating. So when the two plates coincide with each other, you will get a rupture. On that rupture, they provide a fault. From that fault, you can get the earthquakes. That is the reason for getting the earthquakes, because the faults. This one is giants. Why it means giants means you have to, whenever you are going to design the tunnel, we require giants. How the giants are affecting the tunnel direction, tunnel orientation, and stability of tunnel. For that, we require giant data. So based on giant data, you have to design your you have to design, or you have to align the tunnel direction, tunnel shape, and tunnel shape also. So it is a divisional plane or fractures along which there has no relative displacement, or any fracture without any movement is called joint. So a fracture is there without any joint window, that is called as joint. Nature of joints: it is maybe a open joint, closed joint, smooth joint, rough joint, smaller joint, master joints. Master joint means it is a controlling joint of the entire rock structure. So these are joints. So you can see here joint one, that is this is the open joint. Joint two is the closed joint. Joint three is the smooth joint. This is the rough, between the two planes, two layers. It having the rough nature. Like this, it will be having undulations inside the joint. Okay. There's small giant means small fissures, or master giant. Master giant means throughout the formation of the bed from bottom to the top of the entering into the giant. That is called master giant. Okay. So now I will show how the tunnel is designed. So the tunnel design matches with the how the tunnel is going to design. It will depends upon the type of the it will depends upon the type of the tunnel, then how the disturbing force acting on the during construction time, then how the tunnels are provided gradients. So these are the, when you do the tunneling, it depends on the groundwater conditions, the length and diameter of the tunnel drive, depth of tunnel, logistics of supporting the tunnel excavation, the shape of the tunnel also will affect the shape. So now I'm showing the your tunnel design. There is a software called Phase 2. This is developed by the rock science. Developed by the rock science. Okay. This is the Phase 2 software. So here, first is analysis. In the analysis, we have to give, it is a plane strain and axisymmetric. Plane strain means in along plane, two dimensions, other dimension having the strain is zero. That is longitudinal strain or transverse strains, means normal strain as well as shear strains are zeros in the plane strain conditions. Means you are taking the long length of the water. Means if you take the dam, for the dam you can take that as a plane strain condition. Then axisymmetric, nothing but if the axis of the geometry will be cutting the equal plane. If you cut the geometry, it will get the equal planes, that is like symmetrical planes. Then you can go for the axisymmetric, nothing but if you take the I section, it is, if you cut the middle of the I section, it will give us a two channel sections. Okay. First you have to give the which condition are going. Then you know about the mathematics, you can know study about the elimination methods. For matrix methods, this is a fundamental method software. For matrix methods, you have to do the analysis of the matrices by using the Gauss elimination method, or conjugate gradient, or pre-conjugate gradient. Okay. This is the properties for units. Stages. If you have different stages, means you want to, the diameter of the tunnel is more, you can go for different stages of excavation of the tunnel, because you cannot excavate around 20 meters tunnel at a time. You have to go for heading and benching, nothing but first head will be opened, then from the heading it will go for the benching. Okay. Then stress analysis. So for simple calculations I have taken the 500 iterations, means for each an element it will calculate the 500 times of the iterations, then it will give the result. Then tolerance limit of the analysis, then steps, auto steps. Then if there is any groundwater present in the site, provide your groundwater layer, table layer, the statistics, then strength reduction, this is usually for the slope stability, then project summary. So you have to give your project tunnels, project title, means I have given the tunnel design for anything. Okay. Then analysis type, then author who is given the design, who is in the tunnel, then company name, then date, then comments. If you have any comments, you can add comments. Okay. Then for drawing the tunnel, I've taken the import as DXF. That is meant document exchangeable folder, exchangeable file. Means I've taken the DXF file from the AutoCAD. So before that, I've created a tunnel shape from the AutoCAD. That shape will be driven by the DXF file. Okay. So I've taken the excavation import. So I have given the folder name. So from this folder, you have to give the dimension of the tunnel. So my tunnel diameter is this much. Okay. This is maximum ratio, minimum ratio. Okay. Okay. So this is my tunnel shape. Sir, are you able to see the sir? Okay.
Yes, sir.
Okay, sir. Okay, sir. This is the tunnel shape. I have taken the D shape because of the simple calculations. I have taken the D shape. You can take circular also. You can take horseshoe shape also. You can take rectangle. Means rectangle means you take the rectangle. There is a problem of a corner problem. So for in the rectangle shape, the corners is having more stress. Then the corner parts will be damaged because of the huge stresses. After this, add external because I'm in the box type. Okay. This is my box. Means assume this as a rock. Assume this as a rock material. Okay. Then meshing. Mesh type. Okay. For simple bed, I can take graded meshes. Graded means whatever the problem occurs, opening at the time I give the graded means because I want to do the meshing. Detect different types. Uniform meshing will given through the excavation, or you can take the graded, or you can take radial measures. Radial means you can the tunnel will be the tunnel will be the axisymmetric tunnel. Tunnel will be axisymmetric. That must be axisymmetric. For that only you are taken the radial meshing. Okay. Then next triangles. So for each you know about the FE methods. Whenever you give the nodes, node 1, node 2, node 3, they are having different triangles and quadrilaterals. So from this you can take the nodes. So for simply for less accurate, you can go for 3 node triangles. If you require more accurate of the result, you get the 6 node triangles. Then you can go for 4 quadrilateral nodes or 8 noded, whatever the assume you can take it. Then expansion factor is 3. Default number of nodes on the all sequence is 75. Okay. Okay. After this, mesh is given. Then discretize. Okay. Next setup is taken 3 so that taken 3 then discretize, then mesh. Okay. So now this is the message occurred on the my tunnel shape. That means I have taken the from the tunnel above load is around 3 times the tunnel height. Okay. So from that, then for loading. So can I give the full stress how the load is acting on the ground? So I taken the gravity loading. In gravity loading, you can give the what is the soil gamma, that is the soil unit weight or rock unit weight. What the ground surface elevation? If I know the surface of the ground, maybe 100 meters, then rock value is 0.27, then okay. Then after loading, then I have to go for material properties. For that, I have given the different material properties, different material. So I can write as rock or solid rock or strong rock. Can I give name strong rock? Okay. Then I'll give the color of the material. Then field stress. You can take the field stress only. If you don't have any body stress, you can go for field stress. If you have only body force, you can take body force. If you have both loading on the site, you can take for field stress as well as body force. Then I have to given the gamma unit weight of this rock. Maybe I given the 27. Okay. Then properties isotropic, that is elastic properties, or transverse isotropic, orthotropic, or some other method is known as Duncan Chang hyperbolic method. Then Poisson ratio of the rock, maybe I given the 0.25. Then Young's modulus means Young's modulus from the rock. That is about the Hooke's law. So strain direct proportion to stress. So stress is equal to proportion to strain. Therefore stress is equal to strain into Young's modulus. Okay. For that you have to give Young's modulus. So I given as 25,000. Here they are the failure carriers. Failure means how the rock is failure, how the giant is failuring. For that, in the rock in soil or in rock, different types of wedges are there. So you can go for Morcolum, Hook Brown, Drucker Pager, Zenes Hook Brown, Cam Clay, Modified Clam Clay. These are different authors, different failure paints. You can go for the criteria. So based upon the field data, you can select the type of the failure criteria. Okay. If you don't, this is a software called Lock Lab. From Lock Lab, you will get the field data. So if you take elastic, the material will not fail. Elastic low, material will not fail. Elastic means whenever the load is given, the material will go to deform. Whenever release the load, the load is rebound. So the material will not fail. For plastic means it will yield some point. After that, if you remove the load, it is a permanent discharge will be there. So that the material will fail. That's why I'm taking the plastic condition. Then tensile strength of the rock. You know that rock is good in compression, weak in tension. That's why I'm given the only 1 or 0.5. Because rock is a good compressive member, it is having a less tensile member. Then dilation angle means how the rock is dilated, 0 degrees. Then this is the main property of the rock. Friction angle means whatever the bonding between the particle to particle in the rock, that will give the friction angle. It will be calculated from the laboratory, from the diet shear test or triangle test. Means you are applying the stresses on the 3 directions, giving the load. Then how the rock is failuring. From that you get in the stress strain graph. From that you will get the maximum value of the friction angle. Okay. Can I take the friction angle is 36. So residual means after failure how much? I will get 1 degree. Then cohesion, I will take cohesion as 5. So friction residual is 4. Then okay. You can see wherever you move the cursor, you will get the property of rock. Definition of that is what the property given to the material. I have given the material. Okay. Then after that, I have to excavate. So right click on the tunnel opening, assign material, excavate. Means it is excavated. So now I am removing the opening in the rock. Means assume that as a, if I assume as a balloon, if you have a balloon, if you fill with a balloon with the air, how it look like? It look like a round circle of balloon. When you take a needle for the balloon, if you punch it on the anywhere in the balloon, it will blast. Like that, before the excavation of the tunnel, the rock is in good condition. The stability is good. The stresses are good. Whenever you are releasing the stresses by opening, so you are opening a rock mass by giving the small disturbance to the rock. Then there comes a disturbance of the stability of the rock mass. That's why there is a trying to give trying to close the tunnel. So tunnel ఏమైందంటే ఆటోమేటిక్గా trying to close the, because of the stresses coming from the all over the shape of the tunnel, it will try to shrinkage. For that purpose only you are giving the lining. Lining means a steel member you are giving, so that whatever the load coming onto the rock from the tunnel, it will give support. Then it will easily you can use for the passage of roads or rails or road traffic. Okay. So properties is given. Of properties I have given this one. Then after this I have to do the compute. So you can do the compute. So I will give this as a demo as okay. Then you can see the pop-up window, the window showing that how it is calculated. It is over. Then you can see the interpret, means you get the results. Okay. Now you can see the results of the this one of the tunnel. So I will show next stage, that is stop sharing. I will show the results. So how it is showing. This is you can see. Are you able to see, sir? Yeah.
Yes.
So you can see how the tunnel is going to fail. That is called interpretation of results. Now you can see the here total displacement. You can see here at the bottom of this it is showing that 0.0016 meters is the displacement. So for that also you can do the label contour. Okay, you can see here the red button. It is showing the displacement values throughout the length. There is the no change in the stress, means there is no change in the failure of the around. So you get maximum failure is occurs around the in these areas, means in these areas you will get the maximum stress. You can take displacement, then you can take for the elements. So I can remove all this. Clear. See how it is load is acting here. Are you able to see the force acting? So
Yeah.
you'll have force
Yes,
acting.
sir. Yes. Okay.
So this is the because of the surrounding rock mass trying to minimize or closing the boundary. So మనకు కావాల్సిన shape రాదు. We don't get the exact shape of what we're getting the final output. So these are the stresses coming into the to close the opening. That's the problem. These are the yielded elements. These are the forces coming to close the boundary. That's why for this you have to give the here you have to give the lining so that the concrete members are lining the steel members because steel having more tensile property. For that you are providing a tensile members steel. It will take care of the loading coming from the surrounding rock mass. Okay, are you able to see, sir?
Yeah. Yes, sir.
Yes, sir. These are the elements. Also you can see the boundary. Okay, I will remove all these ones. Okay, so remove the counters. These are the stress trajectories around the tunnel opening. What are the stresses are there? You can see this is the final shape, means it will come like this. Whenever the loads are more, it will get like this. See the shape is moving it like this. Okay, this is the yielded shape of the tunnel final put. For resistaining this one you have to give the support so that it will the required dimension of the tunnel will be getting for your purpose. Okay, okay, sir, my time is over.
Yeah.
Class is
Yeah.
over.
Thank.
If
Thank
any doubts you
you.
can ask. Any doubt you can ask.
Thank you. So I request the from the participants, you have any queries, so you can ask. Sir, I request the participants. Sir, how to know the properties of the entire rock are same or not?
Yes, sir. Yes, sir. For that, you have to do the field testing, sir. Field test. From the field
Uh-huh.
test, you have to collect the rock data, rock samples, and do the test in laboratory. There are some institute tests there, sir. Diet set test or boring means you can
Uh-huh.
bore the depth of the whatever doing the drilling, sir. Boring is kada man water kosamu.
Yes.
Same boring will be used. It will drill throughout the length of the depth of the rock. It will
Uh-huh.
collect the rock sample from the boring. A rock sample ni laboratory test chestam. So that you can get the
Okay.
values. You get the friction angle ఎంత ఉంది, పై ఎంత, strength ఎంత, compression strength ఎంత, what is the Young's modulus, what is the strain, what is the stress can be
Okay.
calculated from the laboratory. So for that we have to go to the site, visit the site and take the joint data. I given the strike and dip directions. For that also I given the strike and dip. So here I given only control model. Control means I don't give any joints. So another method is there by giving the joints. If I give the joint data means the how the joint is varying, joint strike, joint dip is there. then it will get more clarity of the rock mass. I have given the only rock as a huge rock mass, means that is a strong rock. That's why I named the strong rock. If I use the weak rock, then I have to give the giant data, means how many giants are there, what are the property of giant, what is the filling of the giant, the opener, closer, smooth giant, rough giant, అవన్నీ ఇస్తే ఆ డేటా మొత్తం I will give, then I will get the data. So I will show how it is showing. I will show the small here how the giant data will be given in the model. Okay, displacements here, support. Okay, so sir, you given the giant, this is a different giant. If I give the giant data, then I give the giant here. If I see like this, okay, properties. Okay, yes sir, is there add a giant, you can see. Okay, giant one, I given the both ends closed like this. Like this, sir. If I give a giant like this, these are different giants. If I give a giants, I can add a number of giants like this. Okay. Then again, I have to give the meshing properties. Yes, sir. Okay. For sake, I'm giving only two giants. If I get exact properties I know, I will give giants. I will clear picture of the site conditions.
Okay.
Okay, sir. Okay,
Thank you, sir. Thank you for
okay,
your
sir.
nice
Thank you.
presentation. So
Thank you,
I
sir.
thank all the participants. Again, we will meet tomorrow. So thank you. With
No, sir.
this,
Tomorrow
I
is
will
all day,
end.
sir. Sir, tomorrow is all day.
Yeah,
Only.
yeah, yes. Monday. Monday.
Okay,
Okay.
sir.
Thank you.
Okay, sir. Thank you, sir.
Sir, Kizar sir, Arun
Yes, sir.
sir.
Yes,
Yeah.
sir.
Shall we close?
Yes, sir, sir.
Okay.
Please, sir.
Yeah.
Yes, sir.
Yes, sir.
Okay,
Thank
thank you,
you.
sir.
Thank
Thanks,
you.
sir.
Okay,
Okay,
sir.
sir. Thank you once again, sir.